G'day guys, my name is Mark, I'm from Dynex Hobby. Today I'm going to introduce a brand new product called TurboScan. TurboScan is a new product that we developed especially to monitor gas turbine engines typically used on radio control model jets and UAVs. The TurboScan system consists of a simple board like this, which can be mounted in your model or can be mounted on the bench. It's connected to a PC using a USB cable. So attaching the USB cable to the side port and then connecting that to a free port on your PC. So I guess the question is, why do we need a product like TurboScan? Well, most gas turbine engines have a very short service life. In other words, they operate for roughly 25 to maybe 50 hours before they need servicing. And so why do we have to service? Essentially, the high performance engines that spin in the order of 100,000 RPM, the bearings that are used inside them do wear very quickly over their life due to the high speed and high temperatures they operate in. And so we need to be able to service the turbines within a safe time frame so that we can replace the bearings or service the engine before anything catastrophic happens to the engine. Now, the great thing about TurboScan is it is an engine health monitoring system. It won't predict a failure of an engine, so to speak, but it will actually indicate when an engine is starting to wear very quickly, which might indicate, hey, I think we need to service or have a service technician look at the engine. Now, some of the things that could lead to engine being damaged prior to it being serviced are things such as dust or dirt being ingested by the intake of the engine. This could cause premature wear of bearings or even failure of the bearings. Contaminated fuel, so if you have dirty fuel going through, the fuel is actually used as a lubricant for the bearings. If the fuel is contaminated, it could cause the bearings to erode very quickly and potentially seize as worst case scenario. Okay, now we're going to attach TurboScan to a spare port on a laptop. So I'll do that, like so. And you'll notice that on TurboScan there are two connector pins. There's one pin which is labelled for turbine and another for the compressor. So on the gas turbine engine we have the turbine side and the compressor side. You'll notice that on the compressor side there is a sensor attached to it. Now these are actually industrial accelerometers which are very sensitive devices used to detect vibration on the gas turbine. And that's actually used by our system to identify if there are any sort of defects in the engine and the general health of the system. So a close-up of the gas turbine, you'll see there are two brackets mounted, one for the compressor, one for the turbine. The turbine bracket picks up on one of the fasteners on the back cone of the engine, and the accelerometer is actually screwed to the bracket via a nut on the underside. In a similar fashion, we have the sensor on the compressor side attached to a spare fastener, which is used to attach the compressor housing to the shroud here, and that's connected by a bracket which the accelerometer actually screws into as well. So you'll have two sensors, one for the turbine and one for the compressor. Now it's important to note that when installing these sensors to the turbine engine, it's actually important to get the sensor to point towards the centre of the shaft of the engine. So in other words, the turbine sensor points towards the centre of the shaft and the compressor sensor points towards the centre of the shaft as well. And the reason behind that is that you want to measure the maximum vibration of the compressor wheel and the turbine wheel, and it's more effective if the sensor points towards the shaft of the engine to do that. Now we're going to connect the sensors to the TurboScan unit. To make it easier for this demonstration, I'm just going to rotate that around like so. So you'll see the two ports for compressor and turbine. So now I'm going to connect the compressor sensor to the TurboScan. Now the black wire faces the top of the label, and just follow the labeling on top here, which illustrates how it's connected. So I'm going to connect that in first, like so. And then I'm going to get the turbine sensor, rotate it so the black label is on top, and connect that as well here. Okay. So now TurboScan is connected to the engine. So you've got your two sensors, TurboScan connected to your PC. Now we're ready to test. So for this test, we have our Wren gas turbine attached into a frame. Now this frame is really built just to simulate an engine sitting inside a model, but you could test the engine, outside the model. Now, one of the things to note is that whenever you test an engine, it must be tested in the exact configuration every time you run the test. And the reason being is that we want to measure the engine's performance or its health in its good state. In other words, as soon as the engine is purchased from a manufacturer or straight after service. So essentially we want to measure the health of the engine in its good state. And then over time you want to measure the engine's health or its performance in increments, but it must be measured in the same state that you measured originally.